the Big Bang Theory, how the universe began. In today's video, we're diving deep into one of the most fundamental questions in cosmology. How did the universe begin? We'll explore the Big Bang Theory, the evidence supporting it, and the fascinating journey of the universe from its birth to its current state. We'll also delve into the origins of the term Big Bang, what existed before the Big Bang, and the impact of these cosmic events on life on Earth, including the era of the dinosaurs. So buckle up as we embark on this cosmic adventure. Welcome, space enthusiasts. Today, we're unraveling the mysteries of the universe's origin with the Big Bang Theory. But before we dive into the science, let's start with the origins of the term itself. Where did the term Big Bang come from, and who coined it? The term Big Bang was actually coined by British astronomer Fred Hoyle during a BBC radio broadcast in 1949. Hoyle, who was a proponent of a competing theory called the steady-state theory, used the term somewhat dismissively. However, the name stuck and has since become the widely accepted term for the theory of the universe's origin. The Big Bang Theory proposes that the universe began as a singularity, an incredibly dense and hot point, approximately 13.8 billion years ago. This singularity then began to expand and cool, leading to the formation of all matter and energy in the universe. This theory is supported by a wealth of observational evidence, including the cosmic microwave background radiation and the redshift of distant galaxies. What existed before the Big Bang? This is one of the most intriguing and challenging questions in cosmology. According to the theory, time and space, as we know them, began with the Big Bang. Therefore, the concept of before the Big Bang might not apply in the conventional sense. Some theories suggest the presence of a multiverse or a cyclical model of the universe, but these remain speculative. Approximately 13.8 billion years ago, the Big Bang marked the birth of our universe. Initially, the universe was extremely hot and dense. As it expanded, it cooled down, allowing for the formation of fundamental particles like quarks and electrons. Within seconds, protons and neutrons formed, leading to the creation of simple nuclei. In the next 380,000 years, atoms began to form as electrons combined with nuclei, giving rise to the first elements. The effects of the Big Bang are not just limited to distant galaxies. The elements created in the early universe formed the building blocks of stars and planets, including our own Earth. Fast forward billions of years, and we reach the age of the dinosaurs. These magnificent creatures roamed the Earth approximately 230 to 65 million years ago, thriving in a world shaped by cosmic events.
When I say we, just the scientific community, physicists who concern themselves with the very early universe, cosmologists, that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours, because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out sort of the same in the very first instant, a later instant when other laws of physics manifest could be slightly different.
It's interesting, this idea of the Big Bang created the universe. That's what Einstein's theory says. That's textbook cosmology, if you like. But the current textbook picture is there was a phase in the universe's life before the Big Bang, if you define the Big Bang as the hot, dense phase from which the universe appeared to sort of burst forth 13.8 billion years ago. And that phase is called inflation. So that sounds fanciful, but that's standard cosmology at the moment. The big question then is, well, what started the inflation? What stopped the inflation? How long did the inflation go on for? And so some of these theories, they're called eternal inflation theories, suggest that there might not be just our universe, the bit that we can see, but there might be many universes, perhaps an infinite number of them, and they may be being produced all the time.
Was the Big Bang really the beginning of time, or did the universe exist before then? Such a question seemed almost blasphemous only a decade ago. Most cosmologists insisted that it simply made no sense, that to contemplate a time before the Big Bang was like asking for directions to a place north of the North Pole. But developments in theoretical physics, especially the rise of string theory, have changed their perspective. The pre-Bang universe has become the latest frontier of cosmology. The new willingness to consider what might have happened before the Bang is the latest swing of an intellectual pendulum that has rocked back and forth for millennia. In one form or another, the issue of the ultimate beginning has engaged philosophers and theologians in nearly every culture. To be specific, consider what has happened over the 13.7 billion years since the release of the cosmic microwave background radiation. The distance between galaxies has grown by a factor of about 1,000 because of the expansion, while the radius of the observable universe has grown by the much larger factor of about 100,000 because light outpaces the expansion. We see parts of the universe today that we could not have seen 13.7 billion years ago. Indeed, this is the first time in cosmic history that light from the most distant galaxies has reached the Milky Way. The Big Bang theory is supported by a multitude of evidence. One of the most significant pieces is the cosmic microwave background radiation, CMB, discovered in 1965. This faint glow, observable in every direction, is the remnant heat from the Big Bang. Additionally, the abundance of light elements like hydrogen and helium observed in the universe aligns perfectly with predictions made by the Big Bang nucleosynthesis models. From its fiery beginnings, the universe has evolved dramatically. The first stars, known as population 3 stars, formed from primordial hydrogen and helium. These stars created heavier elements through nuclear fusion, which were dispersed into space when the stars exploded as supernovae. This enriched interstellar medium allowed for the formation of new stars and galaxies, leading to the complex structures we observe today. Understanding the Big Bang and the origin of the universe not only satisfies our curiosity, but also helps us comprehend the fundamental laws of nature. Finally, let's consider what the Big Bang teaches us. This theory shows that the universe had a beginning and is constantly changing. It also helps us understand our place in the universe. Imagine, the atoms in our bodies were once inside the stars. As Carl Sagan said, we are stardust. As we continue to explore and uncover the mysteries of the cosmos, we inch closer to answering some of the most profound questions about our existence. Thank you for joining us on this journey through time and space. If you enjoyed this video, please like, share, and subscribe to our channel. Hit the notification bell so you never miss an update, and leave a comment below with your thoughts or questions. Together, let's reach for the stars.